All right, today we're going to pull back the curtain on a piece of invisible magic that lets our devices get online. It's a protocol called DHCP, and honestly, it is the unsung hero of pretty much every network you have ever used.
I mean, think about it. It's something we totally take for granted, right? You walk into a cafe, you pop open your laptop, and bam, you're connected. But how does that actually happen? How does your device get the right address and, permission to join the network so fast? Well, that's exactly what we're going to break down.
Okay, let's get right into it. To really understand why DHCP is such a hero, you first have to picture the absolute chaos of a world without it.
Without DHCP, you'd have to manually type in a unique IP address, a subnet mask, a gateway, for every single device. Yeah, your phone, your laptop, your smartwatch, all of them. It would be an absolute nightmare. So tedious, super easy to make a mistake like giving two devices the same address, and just completely impossible to manage for more than a handful of devices.
The best way to think about DHCP is like an automatic receptionist for your network. A new device shows up, DHCP says hello, hands it a unique IP address from a pre-approved list, and gives it directions, like the gateway address it needs to get out to the internet. Simple as that.
So does it just give you that address to keep forever? Nope. And that is actually a key part of what makes it so smart. It uses a leasing system. The address is only yours for a little while. This is so important because it allows old, unused addresses to be automatically recycled and handed out to new devices. It keeps the whole system running smoothly.
Okay, so how does a device actually get one of these temporary leases? Well, it all comes down to a really simple four-step conversation. And lucky for us, it's got a great acronym to help us remember it: DORA.
DORA stands for Discover, Offer, Request, and Acknowledgement. You can literally think of your device as Dora the Explorer, shouting into the network to discover a server. A server then makes an offer. Your device requests to accept that offer. And finally, the server acknowledges that the deal is done. It's this simple four-step dance, happening in milliseconds every single time you connect.
All right, let's break down that little chat. First, your device sends out a broadcast, a discover message, basically yelling, "Is anyone out there?" Any DHCP server on the network can hear this and reply directly to your device with an offer. Now here's the clever part. Your device broadcasts a request, yelling to everyone, "I'll take this specific offer." This does two things. It tells the server it chose yes, and just as important, it tells any other servers that made an offer, "Hey, thanks, but no thanks, you can have your IP address back." Finally, the chosen server sends a final acknowledgement, and the deal is sealed. You're on the network. But wait, what happens when your lease is about to run out? Does your connection just die? Thankfully, no. At the halfway point of the lease, your device quietly sends a message to the original server, just asking to renew. If it doesn't hear back, it gets a little more anxious. As it gets closer to the end, it starts broadcasting its request to any server out there that's listening. The whole system is built for resilience, just to make sure you stay connected.
So that's all the theory. But how does this actually play out in the real world? Let's look at how a typical network router, like the one in your house, can play three completely different roles when it comes to DHCP. First up, and this is the most common role in small networks, the router itself is the DHCP server. It's the receptionist for your own local network, managing the list of available addresses and handing them out to your phone, your computer, and anything else that connects.
Now, if you were setting this up, the order you do things in is critical. The very first step is always to exclude certain addresses. You got to tell the router, hey, don't give out these specific IPs because you need to save them for important things like servers or printers. After that, you create a pool of available addresses, and then you fill in the details for that pool, like the network range and the DNS server. And how do you know if it's all working? Well, network admins have some really cool tools to see what's happening. On a Cisco router, for example, a simple command gives you this live table, a binding table, that shows exactly which IP address is leased to which device, and even when that lease expires. It's an amazing tool for troubleshooting.
Okay, on to the second role. What happens if your DHCP server isn't on your local network? What if it's somewhere else in the company? Well, remember those discover messages? They're broadcasts, and routers by default do not forward broadcasts between networks. They stop them cold. So the router needs to become a helper, or what we call a DHCP relay agent.
And the solution here is surprisingly elegant. It's just a single command, IP helper address. You put this command on the part of the router that's facing the clients, and what it does is it catches that broadcast message, packages it up as a normal message, and sends it directly to the real DHCP server wherever it might be. Pretty slick.
But here is a fantastic bit of networking trivia. That one little command, IP helper address, it does way more than just help out with DHCP. By default, it actually forwards broadcast requests for a total of 8 different services.
And here they are. So on top of DHCP, it's also relaying requests for things like DNS, the time service, and even some older protocols. The point is, this one command is a super versatile tool for centralizing a bunch of different network services, not just IP addresses.
And that brings us to the third and final role, which is how most of us actually get on the internet at home. The router itself has to act as a DHCP client. The port on the router that faces the outside world, the one plugged into your modem, it needs a public IP address from your internet service provider. And how does it get it? By asking for one, just like your laptop does.
And the configuration for this could not be any easier. It is literally just IP address DHCP. That one line tells the router's interface, hey, go out there and get your address automatically. This is the secret sauce for why most home routers just work the moment you plug them in.
Okay, so let's tie this all together. What's the big takeaway from all this? Why should you care? Well, we've basically just demystified the one thing you do every single day, getting online. That seamless connection isn't magic. It's Dora. Every single time you join a network, your device is running through that 4-step dance. Discover, offer, request, acknowledge. It's a predictable, reliable conversation that's happening constantly, right under our noses.
And knowing this is actually a superpower. It's the absolute first step in troubleshooting any network problem. If you ever can't get online, the first question you should ask is, did I even get an IP address? A quick command like ipconfigure_all can tell you if that Dora process failed, pointing you right into the heart of the problem. So, I'll leave you with this final thought to chew on. Now that you know how leases work, think about this. Why would a network admin set a really short lease, maybe just 2 hours, for a busy coffee shop's Wi-Fi, but a really long lease, like 7 days, for a corporate office network? What problem are they trying to solve in each place? Thanks for digging into this with me.